Uh, Now we exclusively see the line regulation of a regulator. So we are having a regulator, a 12-volt regulator. Now here we can see we have connected a DC voltage source. We have replaced the bridge rectifier using a DC voltage source. This is the regulator input. This is the regulator output to which we have connected a 1K resistor. Now you can see we are using a different simulation command, that is .dc. So let us try to identify what does this mean. So if I click on this, now earlier we used to do this transient analysis. Now we are doing a DC sweep. So this DC sweep analysis is used whenever you are changing the DC voltage. So now the required thing to do in this simulation is, so we are supposed to find. Now here in line regulation, since we are varying the input voltage, so we are specifying the particular voltage source V1 which you are sweeping. This is V1. Even though 20 volt is specified here, but it will be overwritten by the simulation command which is being specified in DC sweep. So here I am specifying the DC sweep type as linear because I want to linearly vary the voltage from 0 to 20 volts in steps of 0.1 volt, so that we can get smooth graph. The x-axis is varying from 0 to 20 in steps of 0.1. That means for every 0.1 volt increment we can see what is the output voltage, so that we can clearly see the graph. So now we can see the circuit diagram is done. So this is a voltage source. So by this simulation command, we are varying the voltage source V1 from 0 to 20 in steps of 0.1 volt. So the load is connected with a 1K resistance. Let me just simulate and see. So now let me see the input voltage here, which is okay. One more thing you have to observe here is whenever you are doing DC sweep, the x-axis by default happens to be the identified voltage source which you are sweeping. So in this particular case, it is the input voltage which is 0 to 20 volt. You can see by default it is coming. So since I placed the input voltage both on y-axis as well as x-axis, you have a straight line of 45-degree line. So like having same parameter on both x and y-axis will end up with a slope of 1. So let me also include the output point here now. Let me add the trace. The trace to be added is regulator output. Now you can clearly see uh, this is your output voltage is gradually increasing. It is almost going along with the input voltage with a difference of minimum voltage required. And over here you can see the output voltage becoming constant. So here if you actually measure what is the input and output voltage at each and every point. So this is both the cursors are in input. Let me put one on the input and one on the output. Let me put over here. Now you can see, so when the input is 10, output is 9 something. So if I move it here, now if we just make both input and output at the same time. So you can see the input is output is 10.9, input is 11.9. So always a difference of 1 volt is there. So after the input voltage exceeds that 13 volts, so you can see now the output voltage becoming constant and the input voltage is around 13. Now you can see it is 13 point something. So it is 13.05. At that point, the output voltage is almost saturated to 12 volts. It is 11.98. For any voltage beyond 13, now you can see the input voltage is increasing. Now it is gone to 15 volts, 17 volts, 18 volts. But you can see the output voltage is remaining constant. Meaning that this blue line, which is seen over here, is a line regulation graph. So we know that line regulation is plot versus, it is the plot of output voltage versus the input voltage. Here you have the output voltage in blue line, the x-axis is the input voltage. So we have this as your line regulation, which we actually plotted in the class. The line regulation is initially a linear one and then it becomes constant. So this linear one, you can see the slope is less than 1. that means when the input is around 10, the output is 9. The input is 5, output is 4. So that's how you can see the line regulation. So as you can see in line regulation, we are having a constant load and the input voltage is varied from 0 to 20. You are seeing the output voltage variation. The output voltage varies linearly till the minimum voltage is crossed. So once your input voltage crosses a minimum voltage, output is stable. So if you want to utilize this regulator, the input should be always more than the minimum 13 volts for this particular IC. So next we shall see the load regulation. Now there is a slight modification in the circuit for load regulation. So as we know that, as the name itself indicates, in load regulation we are changing the load current. So now the input voltage is constant, which is kept at 20 volt. Earlier also it was constant, but we are doing a sweep using .dc. Now you can see there is a change in your simulation command also. From .dc it has become .tran. So .tran you are sweeping the, of course you are seeing the time up to 1 millisecond, what is the response of your output. This is your input to the regulator. See here, the R1, which was constant earlier as 1K for line regulation, has been now made a variable register, and this parameter RVR is used or is varied using this dot step command. See here, this is dot step param, RVR is varied. Now here it is given as list. So for different values of resistance, so this list corresponds to the value of R1 is varied from 1K, because now it is 1K once, next it is 100 ohm, 10 ohm, 7 ohm, 5, 6, 5, 4, 2, 1 and 0.1. Now these are the values of different this value of R1 is varied from this to this, then it is this, then it is this. So these are the values of your load resistance. So let me just run this program and see how does the waveform looks like. I'm just running. Let me remove the line regulation. Let me see only the load regulation. So here I'm seeing the load regulation. Let me see the input voltage is constant at 20. Let me see the output voltage. You can clearly see the output voltage. Output voltage is not constant. Now I have different lines for this output voltage. So let me just have two plots. Let me have a plot here. So let me just put this input on one plot, output on the other plot. So if I click on the regulator output, now since it is swept for different values of resistance starting from 1K, 100 ohm, next it is 10 ohm, 7, 5, 4, 2, 1, 0.1. So that's why we have different output voltages. Now you can see you can use the arrow key and then go from one curve to other curve. So the first one you can see it is at 12.00, which corresponds to the least current, which is result of a 1 kilo ohm resistor in this particular example. I'll just move to, so this is, let me select this. I'm just moving from, let me now verify the output voltage for different values of resistance, as you can see from this V regulator output. So you can also see the input voltage is constant at 20 volt for all the values. So I'm not interested in what is the variation, okay, how does the input voltage changes, because there is no change. Let me just delete this plane. I have deleted, now I have only the output plane. So you can see now this is on the topmost position, which is over here, which is 12 point something, 12.007. So let me use the arrow key, and you can see now I'm just moving from one value to the other one. So I'm just moving now. So it has become 12.0057. No much change. This is for a value of resistance from 1K. Next it is 100 ohm. Next you can see it has reduced to, just have a look at this vertical position of your cursor too. Now it has become 11.9. 98. So this is for a value of resistance, which is the third value in your schematic. The third value in the schematic was, that is 10 ohm. So now let me just again go now. Now it has become 11.97. It has become now 6.16. Now 6.16 may be for the value of resistance, which is 5 ohm. So now we can further go for a different value. Now it is 2.67. The meaning of this is, when the value of the resistance is keep on reduced from 1k to 100 ohm, 100 ohm to 10 ohm, 10 ohm to 7, 7 to 5, 5 to 4, 4 to 2, and 1, 0.1, the current is increasing too much. When the current increases, so as we know that the expected graph of your regulation is, the output voltage should be keep on reducing. So I can see output voltage keep on reducing for increased current. If you are interested in seeing what is the current for corresponding resistance value, we can see that also. We can add a plot, and we can have the trace of currents now here. So let me just add the trace to this pane. So let me add the trace which is corresponding to the current. So let me see different currents. You can see now the current is varying from, if you have a look at this, the current is varying from, okay, now it is you can see now the current is 239 milliamperes. Then it is, okay, let me just change this. Let me select this. You can see 120 milliampere. Now it is 1.1 ampere. Now it is 1.7 ampere, 1.23 ampere. Now it is 668 milliampere. I can see it is variation. This variation in current is due to the variation in the load resistance. So we will not get the graph directly. What we need to do is, we need to take the values of V0 and RL are the value of I0. So we have to plot a graph of V0 versus IL. So that you can do by noting the values of I as well as V0 for different values of R. So you will get the expected graph. So where as load current increases, the output voltage is decreasing.